Okay, so here we are, the last video for organic chemistry and the last video for grade 12 chemistry. Isn't that exciting? So this one is a little bit longer than the last ones have been, but these molecules, amines and amides, are now going to introduce a new atom, a nitrogen. So carbon needs 4 bonds and nitrogen needs 3 bonds. So that is going to influence the structures of both amines and amides. Okay, so these molecules, whether they're amines or amides, have very, very pungent odors. So the molecules that we produce when we break down, any protein-based organism breaks down, produces nitrogen compounds, right? So if you remember in grade 9, the nitrogen cycle, and then the nitrogen can get back in the ecosystem. And when you have a breakdown, then often it doesn't smell pretty. So these molecules, these amines, are often called putrescine or cadaverine. So putrid, literally stinky. Cadaverine is the molecule, one of the molecules produced by a decaying body, which is also often called a cadaver. Okay, so they are derivatives of ammonia. Windex is a chemical, cleaning chemical that sometimes people attribute with the smell of ammonia, but it doesn't. Windex sort of has less and less ammonia in it all the time, but that sort of characteristic smell, okay? So we can call these molecules amines, as primary, secondary, or tertiary, and all it is how many carbon chains are attached, okay? So this says how many alkyl groups. That just means how many carbon chains are attached. So a primary has 1, secondary has 2, and tertiary has 3. And why this matters is this influences how many hydrogen bonds can form, how many and reactivity, but it doesn't really influence the naming all that much, excuse me. So amines have, the general formula is a single N, singly bonded N, nitrogen, and then you'll see with an amide that it's a little bit different. So there are actually 2 ways you can name this. So you can use the prefix, amino. So this molecule here has 1 carbon. So you can call this amino because it's got the nitrogen that's single bonded. And then the longest hydrocarbon chain is methane. So amino methane. But another way you can also name this is where you count the chain and use the ending amine. So methanamine. And it doesn't matter which one you choose, okay? If there is something else attached, or if there is a number attached, then that means the nitrogen is attached on that carbon. So I would do the same thing as before, like the prop here means 3, okay? And then on carbon number 2 is the nitrogen. And then another thing is this N. So what that means is this methyl is attached to the nitrogen. Okay, so not too bad. And then just go and make sure carbon has 4 bonds and nitrogen has 3. So then up here, I'm just going to pick a different color, sorry. Up here, since we only have 1 carbon chain, this is primary. But then down here, now we have 2 carbon chains attached to the nitrogen. So it's bad English. Which is secondary. And then sometimes we use this short form, primary, secondary, tertiary. So you can see that. You might see that in the solutions for the homework when it says to label whether it's primary, secondary, or tertiary. Okay, so aminobutane, draw the 4, and then you just have to draw nitrogen attached. You can do condensed like this, like you can do NH2, or you can do ticks. It doesn't matter. You just want to make sure that the nitrogen has 3 bonds and the carbon has 4 bonds. So then N-ethyl 1-aminobutane. So the 1 is for where the amino is. So number 1. And then on the nitrogen, there's an ethyl. And again, draw it condensed or draw it out. It doesn't matter. So now we have, this one is primary, and then this one again is secondary. Here, this one down here, we have 1, 2, 3, 4, 5, 6. So either 1-aminohexane or 1-hexanamine, whatever you like better. Okay? So when in the properties, it's important to have the free NH bond, then they can form hydrogen bonds with themselves. So amines have higher boiling points and melting points than hydrocarbons because they don't have hydrogen bonds. So when you have the NH bond that can form hydrogen bonds, you're going to get solubility in water because they're polar. Now, a very particular property is that NH bonds are less soluble than OH. So amines boil at lower temperatures than alcohols, but that is really ruthless. These points are more important. Okay, so boiling points of primary and secondary amines are higher because they have the free NH to make H bonds. Okay, and then amines are weak bases. So if you remember from the acid and base unit, they were often called methylamine and things like that. That's what we were talking about. Because again, they're derivatives of ammonia, NH3, which of course is a common weak base. Okay, so amines are prepared by essentially substitution reactions. So something switches. Okay, so again, if you like different colors, get some sort of color to represent iodine. We don't use iodine, we use chlorine as the halogen, but whatever. This is right from the textbook, so they chose this. So we have a halogen, and in order to make a primary amine, we're going to start with ammonia, or NH3, and it's going to switch. It doesn't matter which hydrogen is removed. We'll just do the one that's next to it. Okay, so then they come together to make a hydrogen halide or an acid basically, and then the chain is attached to the nitrogen. So now we get here, this would have been 1-iodoethane, and over here it would have been, now it is 1-aminoethane or ethanamine. And then you can keep going, right? So now once you have a primary amine, you can do the same thing. And so now we could take this and do it again. And you can get to a secondary amine and then a tertiary amine. Okay? So for amides, they look similar to an ester, C double bond O, and a nitrogen. And this would have been important in biology. So this is like a polyamide, which is a protein. So you guys would have talked about amide linkages already, if you took biology, sorry. So we're going to do the same thing. So pick a color to represent whatever's connected to the nitrogen. So that gets the YL ending, similar to the the ester, and then whatever is connected to the C double bond O gets the ending, the special ending. So in this case, in an ester, it was anoate. In this case, it's amide. But then again, when you're looking for an amide, it has to be the nitrogen and the double bonded oxygen are on the same carbon. Okay, so here we have connected to the nitrogen is 2 carbons. So connected to the nitrogen, so we'll use the same configuration as an amide, or an amine, sorry. And then the 3 carbons here, 1, 2, 3, is prop and amide. So you can have a bunch of things attached to the nitrogen. So this says N-propyl, N-methyl. So in a way, amines and amides are kind of nice to name because it's telling you this propyl is attached to the nitrogen and so is the methyl. And it doesn't matter where you put them. So we need a methyl and we need a propyl. And I'm even going to mix. I'm going to do condensed and straight out. That doesn't matter. And then we have bute. Bute. So 1, 2, 3, 4, and then make sure you draw the double bond oxygen connected with the nitrogen. So N-propyl again. And meth. So technically we want nitrogen to have 3, and then sorry, I don't want to squish down there. So we've got N-methyl, N, 1, 2, 3, 4, 5, pentyl, prop, and amide. Okay, so you can do the same thing. So here you look at the nitrogen, how many carbon groups are attached. There's 1 to the left and 1 to the right. So that's 2. So that's a secondary amide. Over here, this nitrogen has 1, 2, 3. So tertiary. This one also has 1, 2, 3. And then this one has 2. So how do you get a primary amide? Well, you can't do this with esters, but you can actually do this with amides. So try to sneak it in somewhere, maybe down here. So a primary amide, which exists, would have nothing attached to the nitrogen. So nitrogen can, an amide can have a nitrogen that just has hydrogens attached to it. So let's say, what's one we haven't done? Heptanamide. So then there's nothing attached to the nitrogen, so I'm not going to use the blue. So then we've got, you still have to have the C double bond O and the N. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, but then the nitrogen just has hydrogens attached to it. So you still need this functional group for it to be an amide, but amides can exist with nothing attached to the nitrogen, whereas esters can't do that, okay? So amides are generally insoluble in water, and again, they get really big really fast. If they're tiny, then you can, it does have an NH bond, so you can hydrogen bond with water. If there is no H bond, like NH bond, sorry, in a tertiary amide, then the solubility decreases, just like we saw with amines. Okay, so the reaction of amides is essentially esterification, except we call it a condensation reaction. Why is it a condensation reaction? Oh, look. Water is formed. How shocking. Okay, so then if you want, use the same colors as you've been using, and the nitrogen. Oh, this one, this is a primary amide. So the nitrogen doesn't have any carbon groups attached, and then the C double bond O attaches back here. So this is ethanoic acid, which makes ethanamide. Sorry, I can't spell. And then this is ammonia, or NH3. You can, so just like esters, you can do hydrolysis reactions, but of course, if let's say this isn't a protein in our body, an amide bond, and it can easily be split with water, that's not good. We're 70% water. So these reactions do not occur as readily. So I didn't even give an example. And you, of course, those of you that took biology will know as well that in order to split a protein, you need an enzyme usually anyways. So this is a difficult reaction, which makes perfect sense. Okay, so again, give the homework a try, and yeah, I hope everything goes well. Thank you.